Writing an absolute value equation. We're going to look at two situations here where you've been asked to write an absolute value equation. One from a word problem and then one from a graph. We're going to start with a word problem because this is really a word problem you could solve without using absolute values. It really isn't necessary. You could totally do this mental math. However, again, we're in an algebra class. We're practicing some new things here. We're practicing writing absolute value equations. So we're going to start with some really simple situations. We're not going to throw you in the deep end immediately and give you complicated stuff. We're going to start with simple ones that, yeah, we could solve the mental math. So we're going to practice writing these equations with these. This way it'll be really easy for you to check and see, does that make sense what I'm writing? Because the word problems are straightforward enough that you can kind of figure out what the answers are on your own. So let's look at this word problem. The average temperature in January in a northern Canadian city is 1 degree Fahrenheit, Burr. The actual January temperature for that city may be about 5 degrees warmer or cooler. Ooh. Write and solve an equation to find the actual maximum and minimum temperatures. So we have a kind of average temperature that's our middle, and we have temperatures that are below that and temperatures that are above that. We're trying to find the extremes that are on each end. So we want to write and solve an equation. Now I've drawn a number line here to help you visualize what's happening. Do you need to draw one? No. Do I recommend it? Sure do, because I'm going to talk about some different features of what's happening here. So on my number line, I've drawn out the average temperature. So the average temperature is 1 degree. That's my midpoint. My temperature goes below that, and my temperature goes above that. So 1 is the middle. It's the midpoint of this range of temperatures. Then they tell me that it goes 5 degrees warmer and 5 degrees cooler. So I know that I have 5 degrees warmer than 1 degree Burr. So I could possibly get up to 6. I also know that it goes 5 degrees less than that 1 degree, even more Burr. So I could get down to -4. So when I look at my number line here, I can really see what's actually happening here. My 1 degree Fahrenheit that was the average is my midpoint. And then my positive 5 and my -5 in either direction is my difference, is the range on either side that I'm moving away from that midpoint. So I have two numbers that they gave me. They gave me 1, which is technically my midpoint, and they gave me 5, and they said 5 colder and 5 warmer, and that's kind of the range or the difference that's happening on each side of that. So how can I use this to come up with an absolute value equation? Let's put those pieces into place. It's a word problem. I need to define my variable. So I'm going to use A for the actual temperature. They're asking for the actual minimum and maximum temperatures. So my equation, inside my absolute value symbols, I'm going to take my variable, which is my A in this case, and I'm going to subtract the midpoint. So I'm finding the difference between my midpoint and that end. And remember, we're talking about a distance here. So we're talking about a distance as a positive, which is why we're using the absolute value symbols. So I want to know how far is it from where I'm wondering about to this middle, and I'm not concerned about direction. So I'm not concerned whether it's a negative or a positive there. I don't have to worry about the order of these. I just want to know how far is it, not which direction. And I want to find out when is those extreme temperatures, when is their difference, their range away from that midpoint, going to be 5. Again, it's a positive 5 here because I'm not worried about direction. I'm not worried about if it's less than my midpoint or if it's greater than my midpoint. So here's my basic setup for an absolute value equation. I've got the number that I'm looking for, my n's, minus my midpoint, that's an absolute value symbols, equals, and then the other side is the difference or the range. How far away from that midpoint am I looking to get? So I have my a minus 1 equals 5. I could solve that. I'm going to check this and see, does this equation actually give me the numbers I want it to? They didn't ask us to solve it. They just asked us to write an equation. So really, this should be circled here. They asked us to write an equation. But I'm going to check it and make sure it actually works because it's easy to flip your numbers around. So if I did a minus 5 equals 1 equals a minus 1 equals 5, I would add 1 and I would get a equals 6. That's one of the numbers I know should work in this temperature problem. And if I do a minus 1 equals -5, when I add 1, I would get a equals -4, which is another temperature I know should work in this problem. Again, we're practicing on one that we can kind of figure it out other ways to see if this is actually working. So our equation here is right there. There's our equation. A minus 1 in absolute value symbols is equal to 5. So remember this because we're going to come back to it in a minute. So let's take a look at writing an equation from a number line. So it's not a word problem anymore. I don't know what's going on. I have this number line, and they're going to plot some points on there for you. So I've got negative 10, and I've got 14. We want to write an equation, an absolute value equation, that gives me those two solutions. So if you remember, we talked about the numbers that are endpoints that we're looking for, minus the midpoint, and that's an absolute value symbols, equals the difference or the range. So how far are those endpoints from the middle? So from my number line with negative 10 and 14 on there, I have to figure out where the midpoint is. So right in between negative 10 and 14 is 2. Negative 10, if I figure out how far these are apart from each other, 14 minus negative 10, I've got negative 20. I've got 28. Divide by 2, and I come up with oh, come on, Ms. McMurray, this isn't that complicated. Yes, so we come up with a 2, because we've got a distance of 12 and a distance of 12. There we are, sorry. So we come up with a distance of 12 for each of our endpoints from the midpoint. So here's my midpoint. Here's my range or my difference. So negative 10 is 12 away from the midpoint. 14 is also 12 away from the midpoint. All right? So when I go to create this equation, in my absolute value symbols, it's going to be x minus the midpoint, my midpoint is 2, equals the difference or the distance or the range that midpoint is from the ends. And they're 12 away from either one of those. So there's my equation. I always check my equations just to make sure that it actually works the way I want it to. So if I put negative 10 into here, negative 10 minus 2 gives me an absolute value for negative 12, which is 12. That works. If I plug 14 in here, 14 minus 2 gives me 12. Absolute value of 12 is also 12. So this is the basic setup that you're going to have for an absolute value equation when you're writing it, either from a word problem or from a graph.